For the question 1, let's begin with the introduction. A chemist needs to prepare 100 liters of an acid mixture with a 45% concentration using 3 available solutions, which is 10%, 40%, and 60% acids. Due to limited supply, the amount of 10% solution used must be twice the amount of the 40% solution. This problem involves finding how much of each solution is needed to meet both the volume and concentration requirements. Next, we go to the problem statement. A chemist has 3 different acid solutions. The first acid solution contains 10% acid, while the second contains 40% acid, and lastly, 60% acid. The chemist wants to use all 3 solutions to obtain a mixture of 100 liters containing 45% acid. The supply of 40% acid is low, so twice as much 10% solutions as 40% solution must be used. Therefore, how many liters of each solution should be used? Do you know what the purpose of the question is? Let me tell you. First, to determine the volume of each acid solution that should be used. Second, to ensure the total volume of the mixture is exactly 100 liters. Third, to achieve a final acid concentration of 45% in the 100 liter mixture. And lastly, to satisfy the condition that the amount of 10% acid solution used is twice the amount of 40% acid solution used. For the methodology, the inverse matrix method is applied to solve this question. Based on theorem 6, we need to get the inverse of matrix A first by using Gauss-Jordan elimination method. In this case, 3 linear equations can be formed based on the total volume we use to determine the volume of each acid solutions, which is 10%, 40%, and 60%. That should be used in the final mixture. For the step 1, we need to describe the variable. Step 2, write down the linear equation from the problem statement. Step 3, state the equation into the augmented matrix form as shown as above. Next, step 4, by using Gauss-Jordan elimination, we perform row operation to reduce matrix A to the identity matrix, where matrix A, identity, into identity, the inverse of matrix A. So the final answer for X is 25, Y equal to 25/2, and Z equal to 125/2. For the conclusion, what we can conclude is we can find how many liters of each solution should be used by using inverse method. Therefore, the outcome for acid 1 is 25 liters, acid 2 is 12.5 liters, and acid 3 is 62.5 liters. We have shown by using inverse method and calculate the volume of each acid solution that must have been used.
Let me explain the situation given in question 2. This problem involves a farmer with 120 acres of land who wants to grow corn, wheat, and soybeans. He plans to plant twice as much wheat as soybeans and 30 more acres of corn than wheat. These conditions are solved using the Gauss-Jordan elimination method to find the exact land allocation. The problem statement is a farmer plants corn, wheat, and soybeans on 120 acres. He plants twice as much wheat as soybeans and 30 more acres of corn than wheat. How many acres of each crop are planted? From question 2, the objectives are to determine how many acres the farmer should plant with each type of crop, which are corn, wheat, and soybeans. Second, to represent the problem as a system of linear equation in the form of an augmented matrix. Third, to solve the system by using Gauss-Jordan elimination method. Let's look at our methodology. The land allocation problem was represented as a system of linear equations based on the given conditions. It was solved using the Gauss-Jordan elimination method, which transformed the augmented matrix into radius row echelon form through elementary row operations. For step 1, we need to define variables, which is x is acres of corn, y is acres of wheat, and z is acres of soybeans. Step 2, we need to form the system of linear equation based on the problem conditions. Step 3, we need to write the system augmented matrix. To solve for the step 4, we apply the Gauss-Jordan elimination method by performing a series of row operations on the augmented matrix. This step helps us simplify the matrix into radius row echelon form, where each variable can be easily identified. Through this process, we eliminate values above and below the leading ones in each row. Once fully simplified, we find the solution where the farmer should plant 66 acres of corn, 36 acres of wheat, and 18 acres of soybeans to meet all conditions given. For the discussion, using the Gauss-Jordan elimination method, the farmer should plant 66 acres of corn, 36 acres of wheat, and 18 acres of soybeans to meet all conditions. This shows how linear algebra helps solve real-world planning problems effectively.
For this case study, we will explore about business scenario involving sports shop that sells 3 types of bicycles: mountain bikes, road bikes, and electric bikes. Each bike type has different price. The sports shop sells mountain bikes for 900 ringgit, road bikes for 1,200 ringgit, and electric bike for 2,500 ringgit. They sold 50 bikes and earned 83,000 ringgit total. They sold twice as many road bikes as mountain bikes. So for this question, we will apply quotient elimination method to answer the question, and we need to write down the equation before start calculation. Next, problem statement. A sports shop sells mountain bikes for 900 ringgit, road bikes for 1,200 ringgit, and electric bikes for 2,500 ringgit. They sold 50 bikes and earned 83,000 ringgit total. They sold twice as many road bikes as mountain bikes. How many of each type were sold? So, the purpose for this case study is number 1, to determine the quantity of each type of bike sold based on total revenue and sales constraints. Number 2, to ensure the total earned for bikes sold is 83,000 ringgit. Number 3 is to solve the problem using quotient elimination method. Method that can be used to solve the problem is quotient elimination method. This method is a systematic procedure used to solve system of linear equation. This method involves a series of row operation on augmented matrix of the system and transform it to the row echelon form REF. Step 1, we need to define the variables. X equal to mountain bike, Y equal to road bike, and Z equal to electric bike. Step 2, we need to form linear equation based on the problem. The first equation is X plus Y plus Z equal to 50. Second equation is 900X plus 1,200Y plus 2,500Z equal to 83,000. Equation number 3, 2X minus Y equal to 0. Step 3, we need to convert the equation into the augmented matrix form as shown. Step 4, calculate using quotient elimination method until we get row echelon method, which is REF. Step 5, we will convert row echelon form to the system of linear equation and solve for X, Y, and Z. The new linear equation that we get is equation 1, X plus Y plus Z equal to 50. Equation 2, Y plus 16 over 3 Z equal to 380 over 3, and equation number 3 is Z equal to 20. By using substitution, we will replace Z in equation 2. So, we solve for Y and we get Y equal to 20. After that, we will replace Y equal to 20 and Z equal to 20 in equation 1. So, we will solve for X and the final answer for X is equal to 10. For step 6, therefore, x equal to 10, y equal to 20, and z equal to 20. Discussion. So, by using Gaussian elimination method, we determined that 50 bikes were sold where mountain bikes sold for 10 quantity, road bike sold for 20 quantity, and electric bike sold for 20 quantities. This case study demonstrates the practical application of linear algebra in solving real-world problems and show its usage in our daily life.
For the question 4, this is the introduction of the case study. This problem involves ticket sales at Carnival, where children's tickets cost 4 ringgit, teenagers 6 ringgit, and adults 10 ringgit. A total of 400 tickets were sold, collecting 2,400 ringgit. It is also given that the number of teenagers is twice the number of adults. To find the number of tickets sold for each group, we use a system of linear equation and solve it using Cramer's rule. At a carnival, tickets cost 4 ringgit for children, 6 ringgit for teenagers, and 10 ringgit for adults. A total of 400 tickets were sold, collecting 2,400 ringgit. The number of teenagers was twice the number of adults. So, how many of each type of ticket were sold?
The purpose for question number 4 is number 1, to determine the number of tickets sold for children, teenagers, and adults. Number 2, to represent the problem as system of linear equation in 3 variables. And number 3, to apply Cramer's rule to solve the system and find the number of tickets for each group.
Next, we go to the methodology. The problem is solved by forming a system of linear equations with 3 variables. Cramer's rule is used, which involves calculating determinants to find each variable, provided the coefficient matrix has a non-zero determinant. Determinant used to calculate the values of each variables by replacing the columns of the coefficient matrix with the constant values from the equation. For step 1, define the variables where x equal to number of children tickets, y is the number of teenagers ticket, and z number of adults ticket. Step 2, form a linear equation based on the problem, then convert the equation into the automated matrix form.
Step 4, calculate using Cramer's rule and find determinant of A, A1, A2, and A3. Step 5, solve for x, y, and z. Discussion. By using Cramer's rule, we determined that 160 children's tickets, 100 teenager tickets, and 80 adult tickets were sold. The value specified all given condition where the total number of tickets is 400. The total value is 24,000, and the number of teenager ticket is exactly twice the number of adult ticket. This case highlights how Cramer's rule provides a systematic approach to solving practical problems that involve numerical constraints and relationship between multiple variables.